I'm always happy to lend a scientist my attention. But after this next segment, I'm having second thoughts about lending one my blender. You'll see what I mean.
Quick, think of the grossest science experiment ever. Did you think about a blended liver smoothie oozing and bubbling with enzymatic chemical reactions? Same. Let's get gross with liver enzymes together. This is bioengineering for beginners. Bioengineers build new tools and medical technologies that work with or mimic our human biology to help people heal or detect diseases. So it makes sense that we look at tools our bodies naturally produce, like enzymes. Enzymes are tiny proteins that speed up chemical reactions in our bodies, like amylase in our saliva, which breaks down complex carbohydrates, or lactase in our small intestine, that breaks down lactose. Without enzymes, these chemical reactions would happen too slowly to keep us alive. So yeah, they're pretty important. But today, I want to introduce you to an enzyme living in your liver. Our liver is a detox center where chemical reactions happen constantly to break down harmful substances within our bodies, like hydrogen peroxide. Seriously. Even though it's toxic to humans, chemical reactions in our lungs, gut, and thyroid gland naturally produce hydrogen peroxide, and our body has to break it down in order to get rid of it. Luckily, our liver has a defense mechanism, the enzyme known as catalase. Catalase turns that hydrogen peroxide into water and oxygen molecules, which our body can then use or dispose of. To see this reaction firsthand, I picked up some liver from the grocery store.
Delicious.
First, we're going to dump the liver in the blender. Then we'll blend this with equal parts water until it's smooth. And there's our liver smoothie. Time for the fun part. So what we're going to do is open our blender, and we're gonna take a drop of our blended liver and put it right in the middle of our plate. And we'll add a few drops of hydrogen peroxide. All right, I'm gonna go ahead and start dropping. Oh my gosh, that's crazy. Look at all those bubbles. And the more you add, the bigger the bubbles get and the more concentrated they are. And that's actually the catalase breaking down the hydrogen peroxide into water and oxygen gas. So this reaction is showing what catalase can do at full strength. But enzymes are sensitive to things like temperature, acidity, and salinity. So let's put on our bioengineering caps and see how catalase reacts under a different condition, like heat. I put this sample in the microwave for 20 seconds to warm it up. Now that it's cooked, let's add some hydrogen peroxide. Wow, it looks like almost nothing is happening at all. But why is the catalase failing? Let's get like an enzyme and break it all down. Catalase is an enzyme made out of protein, and proteins are extremely delicate. When they're exposed to extreme temperatures, they denature. Denaturing is when they unravel and lose their shape and function. It's just like a spring that's been stretched out straight. Once it loses shape, it doesn't work the same anymore. This experiment demonstrates just how precise conditions need to be for regular functions to happen in the body. That's the magic of science. Even a liver smoothie can inspire us to ask questions and use science for good. So remember, live your life to the fullest. See you next time. Bye.
If you're watching this, you must have really liked the video. Make sure you follow and subscribe, and check out these other videos that are even better. No, really. I've seen this one over 100 times.